and distributed computing, peer-to-peer computing, grid computing, cloud computing, and big data analytics. She has published about 30 papers in international and national journals and conferences. She is a life member of IST. She has trained more than 7,500 faculty, students, and corporates on the latest technologies. In addition, she is the administrator of Bethel Group of Schools. Welcome, ma'am.
Thank you, Avantika. Can we start off with the session?
Yes, ma'am. Can start, ma'am. Welcome, ma'am.
Thank you so much, Anandi ma'am. I would like to extend my thankful note to the entire management of Sri SAIRAM Engineering College. A special thankful note to the Department of Computer Science and Business Studies, CSBS, and headed by Dr. Anandi ma'am for having invited me to give a talk on this domain on deep learning. Okay, so I hope you are all enjoying the other sessions. Yes, no? I hope you are learning a lot of things about deep learning tools. All right, and how it has been applied. Not only learning how the tools are there, how do you apply that, right? And can one of you say what was the insights about the previous sessions on deep learning? Do you want the session to be an active session? You want to have an active session or a passive session? I hope you're able to hear me. Active session. Thank you. Thank you, Professor Anish. What about others? Thank you, Ajita ma'am. All right. So today we are going to see about deep learning and for its classification models. All right. Yes, can one of you say what is from your mind perspective the deep learning is? I know you'd be able to speak even more better than me. Feel free to interact a session. Thank you, Professor Balaji. Yes, can you, any one of you say, or can you unmute your mics and say, what is from your perspective deep learning is? We have like 55 participants, maybe excluding me, 53. Or in just one word, can you say what is deep learning? Waiting for your responses. Imitates the way human brain, yeah, exactly said. Thank you. Auto learning, thank you. Interactive processing units, thank you. Then, imitating is AI. Yes, imitating is AI. Thank you. I hope this entire sponsor session, you're having new learnings and the way you come in will not be the way that you go out. All right. So, let me share on my screen. You're able to see in my screen. You're able to hear? Sorry, you're able to see my screen? Can one of you unmute and speak, please? You're able to hear? Sorry, you're able to see my screen?
Yes, madam.
Okay, thank you. So once again, I would like to thank the Department of Computer Science and Business Systems, and they are organizing this ISU sponsored short-term training program, especially on deep learning tools and its application. Today in this session between 2 to 3:30, we are going to focus on using deep learning tools. How will you be able to develop a classification model? All right. you'll be able to develop a classification model. That is what we are going to see as introduced by the MCs. Right, I was in the engineering colleges for a decade, and then I started this concern called as Computational Intelligence Research Foundation. It's a Section 8 company registered under Ministry of Corporate Affairs, Government of India. All right, so coming into this, like basically I'm a data scientist, keynote speaker, a trainer on machine learning and deep learning. All right, so you would have heard about what is data science, right? So what is data science? When you take the word, it's a bigger umbrella, right, that uses scientific methods, scientific processes, the algorithms that extracts knowledge. Your data could be of structured data, your data could be unstructured data or semi-structured data, and you have to apply knowledge and get actionable insights from data across broad range of application domains. All right, so here when you say you're going to extract information from the data, all right, can one of you give any examples from a data set that you would like to extract information from a data? I hope there are researchers working here, right? Your professors. Can one of you say, please? Yes, please. Any data from where and you'll be able to extract information from it. Any model. Healthcare. Exactly said. Healthcare. Very nice. So when you take healthcare applications, when you take healthcare applications, here you'll be able to find whether the particular patient has got a disease or not. Say, for example, if I'm going to take a diabetes data set, what is the level that determines a person is diabetic or not diabetic? What level of blood sugar level? That would determine a person is diabetic or not diabetic.
70 to 150.
70 to 150.
70 to 150.
150. All right. So it differs between your fasting and after that, right? So if it is more than 140 or 150, we say the person to be diabetics. So if I'm going to have like 2 lakhs of data, right? 2 lakhs of data of different patients taken different times of the blood sugar, maybe the urine sugar, their BPs, whether they are heart patients, or so much and so more. Extracting all this information, this deep learning algorithm, as you all said, it's mimicking a human brain, very rightly said. It will try to extract information. If the patterns of this data are so much and so much, then we could define this particular patient as a diabetic patient. If my data patterns is of normally between 70 to 100 or between 120 is the diabetics rate, then we define the patient as a not diabetic patient. All right, so even in data science, that is what, this is one example of healthcare. And now what is more going in different colleges? What season is this in colleges now? June, July, what season we have? I know you're all professors of different colleges, right? What is the season in our college now? Any answers, please? Admissions, rightly said. Professor Nandini, Professor Kumaran sir, and Ajita ma'am. Yeah, sir. So you get a lot of applications. But all these applications are turned to admissions or only a few? Only a few, right? So even you can develop a prediction model taking in concern of your previous 5 years information. If so many applications are received, what is the percentile of applications being transferred into an admission? You can develop a prediction or a classification model. There are 2 things for output, either admitted yes or admitted no. So you can classify, you can develop a classification algorithm using deep learning for this applications. Well said. I'm happy that I'm getting good responses from that. So you're able to understand. So what it is a scientific method, it's a process, it's an algorithm to a system to extract information, either it's a structured data or unstructured data or semi-structured data, and you have to get actionable insights from it. Okay. That's more important. So the most three best Python libraries that we go on for using for data science is NumPy, which stands for Numerical Python, Pandas for data analysis, and Matplotlib for visualization. There are even plentiful visualization algorithms available like Seaborn, Plotly, Bokeh. Okay, I'm going to ask you a question. Let me see the answers on the chat. Anybody here have used Pandas for the research? Pandas, Python package Pandas? Yes means type Y on the chat. If you have not tried it out, type N on the chat. The 74 of us or 73. No? Others? What about others? Yes, please. Just watching Kung Fu Panda. No, not that. Panda is a package. No, as Nilesh sir says, yes, thank you. Yes, thank you, Nandini ma'am. I want everybody to give an answer, either yes or no. Okay, so I'll be showing you a demonstration of how are you going to develop a classification model using the deep learning tools. Some of you say yes, some of you say no. That's fine, right? So when you take into machine and learning and deep learning, both machine learning and deep learning, what it does, it learns, it discovers patterns from the data, right? What is the type of data? How it will be able to discover the patterns from it? So I said, right, if for example from your application, so this is a student from this location and this is the marks he has achieved, whether it's going to be an hostel or a day scholar, whether his siblings studied here or any of his relatives or he's a referral, so much and so more we find it out, and then from the discovering of pattern, then we could assure whether this particular student will be admitted or not. All right, so you learn discover patterns, but what they involve dramatically different techniques. Okay, they like the more accuracy that you can achieve in deep learning than in machine learning, but more predominantly both of them, both machine learning and deep learning, they discover patterns of data. They discover patterns in the data set. Right? So both looks the same, but they are finding the patterns from the data set. So are they are both the forms of artificial. Somebody, one professor told AI is like mimicking the human brain. Yes. And deep learning is a specific kind of machine learning. So you can think AI as an entire sector. The subset of AI is machine learning. The subset of machine learning is deep learning. All right. All right, so both machine learning and deep learning, we'll be working with both training data sets and the testing data set. So we split our entire data set into training data and testing data. Say, for example, if you're going to have 100 rows, or say, for example, if you're going to have 1,000 nodes or 1,000 data or 10,000 data, right? You can split into 80-20 percentage. Like if it is, say, for example, if it is 100, you can have like 80 for the training data, for testing 20. Otherwise, you can make for the training 60 and for the testing 40. And for the other way, you can make it 70 for training and 30 for testing. But what generally I do, right, I always make 70% for training and remaining 30% for testing. But you can implement as which you think, which model is the best and in which you get the best optimization at process. Has anybody worked on machine learning algorithms here? Yes, no? Ma'am, don't ask us question, ma'am. Just take the session you want, or you want to interact. No, okay. Because the level before machine learning is deep learning. Sorry, the way before deep learning is machine learning. All right, and this too is a very good session, post-lunch session. Such a wonderful session, right? I don't know how many of you are sleepily listening to this talk. How many of you are really listening to this talk? Or how many of you come for certificates? So it is the ball is on your court. You can kick it around. Subconsciously listening. Subconsciously listening. Yes. Listen to the talk. We are going to have a game to be played at the end of the session, a quiz. And therein we are going to define who will be the winner of the day or the hero or heroine of the session, right? Listening. Thank you, Saranya ma'am. All right. So it's really wonderful to get good responses. The wonderful responses, subconscious listening. All right. It's wonderful. Okay, so artificial intelligence, you will know what it is all about. It's a machine capable of doing its works. I'm not going to go deep into it. All right, it covers anything how the human brain behaves, right? And then when you take into machine learning, both machine learning and deep learning, it is going to work with discovering patterns of data. Keep that strong in your mind. Keep that strong in your mind, right? So it's a subset of AI, and it gives a machine and it gives the access to the data, and they learn and self-explore. So this self-exploration is not available in artificial intelligence. One example of artificial intelligence is washing machine. Okay, whether washing machine is going to do the task assigned for it or it is going to learn from the data. Please answer, please. If I'm using a washing machine, all right, whether it is going to learn or it will do only the task that is assigned to it. Okay, it will only do the task. But in machine learning is a subset of the deep learning, so sorry, subset of AI here. The system itself will be able to find and learn and explore themselves. Here also extracting patterns of data, extracting the patterns of data, right? Deep learning, it's a subset of machine learning, right? I told, right? And here you use deep neural networks, okay? Deep neural networks are the ones that we are using it here. And so for acquiring better accuracy than that, right? Better accuracy than machine learning. So this is artificial intelligence, then came machine learning, and now it's deep learning. Okay, so both machine learning and deep learning, what are the differences? Both can handle numeric data. I'm going to show an example of numeric data for regressions and non-numeric for classifications, right? So you can use numeric data, non-numeric data, and predominantly it is used for object recognition, language translation. Anybody here works in NLP, in natural language processing? I don't know. Okay, but it provides a better fitting onto the model than machine learning. Okay, better fitting than machine learning. All right, you're able to understand till now? Yes. Okay. So a DL is ML, okay? Deep learning is machine learning because it is a subset of it, right? So it is a programmable neural network. You know how in a brain, how it has been connected, what is the component that connects in a brain? Neurons. We are going to work on a project on NLP for a fintech. Congratulations. Congratulations. Okay. So here you have got a lot of neurons, right? Okay, you've got a lot of neurons that get connected in your human brain. Okay, in your human brain. So there is something called a synaptic connection. Okay, there is something in your brain called a synaptic connection. What is the synaptic connection? When you learn something new that you have not learned before, immediately there is a connection that happens in your brain that is called as synaptic connections, right? So here it is going to use in deep learning a programmable neural network. Okay, that enables machine to make accurate decisions without the help of human beings. Okay, so in machine learning, both machine learning and deep learning, you're going to learn patterns of the data. So algorithm that parses data, learns from the data, and applies learned information to it. Right. So how many of you use YouTube? Did you visit YouTube today? Yes, no? Nobody uses YouTube. Okay. All right. And when you see a YouTube video, can you see the relevant videos being trailed onto your right right? When you see one set of videos, then you will see the relevant set of videos onto your right. All right. And how many of, not today, we are with you. Thank you so much. All right. And what do I want to say? What is the latest product anybody bought on Amazon or Flipkart or any other tools? When you search to buy a product, can you see beneath customer who viewed this product has also viewed this product? Have you ever seen that when you buy products? And anybody can share what is the latest product that you bought on Amazon or Flipkart? Yes, I do understand. Yeah. Yes, Ajita ma'am said that is an example of a recommendation system, right? So customer who view this product has also viewed the other product. In YouTube, when you see a video, there is another video that will be almost relevant to it, right? Almost relevant to it. So these are examples of recommendation system, right? Automated recommendation system. And also, I don't know how many of you have experienced this, right? And when you search something in Google, probably if you want to buy a furniture, a bed, or something or the other, you just search it and then you go to Gmail. Can you ever find the relevant ads being coming onto your right on your desktop? Have you ever experienced it? You search in Google for something, maybe you want to buy a cot or buy a bed or a sofa or something or the other, or mobiles, and then when you open your Gmail or any other application, can you see any ads onto the right? Yes, which means every information that you pinch on your internet is being grabbed, and it itself is an automated recommendation system that gives to you. Sometimes you wonder for it also. All right. And if AI returns to an inaccurate, then he has to make an adjustment. If the accuracy is not good, then as a machine learning algorithmist, I need to re-edit the algorithm to achieve better accuracy. But with deep learning, in every iteration, listen carefully, in every iteration, it will self-learn and keep rebuilding the neural network. Okay, and wherein there will be very, very less interaction of human to take place. But in machine learning, when the accuracy is less, only a human need to optimize the algorithm using hyperparameter optimization or CV or something or the other, or changes an algorithm. But in deep learning, as and when you use deep learning, and every iteration it itself self-learns. Okay, so this is what we say deep learning is more accurate in machine learning. Yes, yeah, Saranya ma'am has given. I have seen in Facebook ads. Yes. Also, when an email is sent, the Google ad comes for a similar domain. Yes. So you need to very understand this capturing whatever you use in internet. It could be your mobile phone, or what do I say? Everything is like seeing an ad, using an advertisement on an open wall. When you go on the roads, right, you see advertisements, wall posters being posted. It is the same way in the internet world. Everything is transparent. Okay, everything is transparent. Okay. One example of difference between machine learning and deep learning is that, like when I'm going to write a machine learning algorithm, so it uses a voice recognition software, right? When I want to turn on whenever I enter into a room when the light is not switched on, I used to say the word dark. When the system listens to the word dark, what it immediately does, the light will switch on in a machine learning algorithm. But in deep learning algorithm, when if I'm not even using the word dark, but I'm saying I can't see, I think the light switch doesn't work. Even if I use sentence of these words, also my DL algorithm will be able to understand, and the lights will be switched on. Whereas in ML algorithm, only one thing works. Only when I use the word dark, then only the light glows. But in DL, even if I'm not using dark, because I told right, in every iteration it self-learns. So I can't see, the light won't work. Even for that, your DL will work for it. I mean, this is a great example. Thank you so much. All right. So now you are able to find out the difference between ML and DL. because every time there is a confusion among even faculties or students, and what does ML say? Somebody says is almost the same. No. You have AI, the subset is ML, and the subset of ML is DL. Okay, in every iteration it self learns. We're very less independent of human, but in ML you have a great dependent on human, right? So deep learning algorithms uses a layered structure of algorithms called as artificial neural, like ANN, convolution neural network, RNN, everything is with a neural network. Today we are going to see a very simple example. I'll run the program and also show to you. Okay, this is like a human brain, right? The biological neural network. Okay, so leading the process that's far capable of standard machine learning algorithms, right? How many of you know this game called as Go? In Chennai, we are just experiencing chess Olympiad, right? And this is another game called Go. Anybody knows about this game called Go? Please don't go away from the session. Do you know the game called Go? There is. In order to understand DL, I should study first AI. Yes, exactly said. Thank you, Sudhama. Okay. So some of you said you don't know. So Google created a computer program with its own neural network. Okay, and to play the abstract board game called Go. Okay, there was a game like chess. There is another game called Go. I'll show that to you. Okay, there are professional Go players, right? So what Google did, it made a computer programming using this deep learning tools, right? Using deep learning tools, we created a model, and that is named as Alphago. That's named as Alphago, right? So this made a human to play with Alphago. Okay, Alphago, it also plays the Go game, but it is developed using a deep learning model. Okay, without being told anything to every specific move. But in machine learning, I need to tell what could be the next move. But in deep learning, I need not tell what would be the next move. And then it defeated the multiple world-renowned masters. All right, this is an example. My entire screen is shared with you. You're able to see my screen, AlphaGo screen. Can one of you unmute and speak? Yes?
Yes, ma'am.
Okay.
Yes, ma'am, it's
Thank you.
visible.
Okay. So this is the game called, this is the computer game, first human Go player. Okay, it defeated the professional human player. The most challenging game because of its complexity. Okay, it's originated in China over 3,000 years ago. Like it's like a board game. Can you see? This is called as a Go game. Can you see? It kind of resembles chess, but not chess exactly. All right. Even the world-renowned players got defeated with AlphaGo. AlphaGo is a deep learning model. Okay, it's a deep learning model, but surely they say AlphaGo is creative. Even without giving any input to the game, it was able to understand the move from the world-renowned players, and it was able to capture it. Okay, capture it. So you are able to understand the difference between machine learning and deep learning. Okay, have these examples. You can go and speak it to the classes, right? This is how students will try to know how different you are from others, right? So the amount of scale of data keep on increasing, right? Even like yesterday, like we had 1 month internship on machine learning for almost 135 students, 135 to 140 students. Yesterday we completed one session. They started from basic Python till the visualization. Maybe for the next batch, they'll come for machine learning and deep learning. The next session is going right now on July 15th to August 15th is data analysis using Python. And again, we have an online session starting on image processing, right from August 1st, September to the end of September. That will be a 2-month session, right? It could be an internship, and anybody, you or faculties or students, anybody interested or corporates also be able to find it. Yeah, IBM SLHS played world champion Gary, before 20 years, DL. Thank you so much for sharing it, right? So now you understood the depth of DL, right? So it's an algorithm in layers. Like you can create how many layers? Generally, I've got an input layer, you've got an output layer, and set of hidden layers. This structure you keep it in your mind. About whenever you think about deep learning, you have it in the input layer, you've got an output layer, and on the middle you've got set of hidden layers. All right, and deep learning is what makes it powerful, like human, like artificial intelligence, right? So if I'm going to so there is something called supervised learning and unsupervised learning, right? This comes in machine learning. So whenever it is supervised learning, I know what is my target. So I told you, right, classification comes under only supervised learning. So I'm going to train all my algorithms using red apple, but during the testing model, what color of apple I'm going to give? What color of apple am I going to give? Can one of you unmute and speak? 100 plus people are here. I don't know how many of you sleepingly listening, how many of you are really listening. Maybe after 2 minutes, I'm going to ask a session. How many of you are listening to the session? Okay, but for the testing, I'm giving a green apple. But the model does not only take the color, it also takes the shapes and finds out and tells me it is also an apple. But when I come into supervised learning, it comes for clustering models, right? If you want to do a clustering operation, like set of students, when you take students in your class, generally using the learning level of students, how many groups of students can we have in our class? You're all professors, right? I can get an answer from you. In generally in any section, right? How many groups of students are there with respect to their learning skills? Nobody unmutes, only answers on chat. 3. What are the 3? Yeah, average.
Advanced, moderate.
Below average. So you can say like above average, average, and below average. So for those kind of applications, you don't have an entire target. For if I'm going to do an exam result analysis, there is only 2 target, pass or fail. That comes under supervised learning. You have a target. This is a patient has got disease or not. That comes under supervised learning. Sorry, supervised learning. Yes, you have a target, right? You've got applications. You're going to admit it, yes or no. Then that comes under supervised learning. So these are all coming under the classification model. Able to understand? When you speak about classification model, you mandatorily have a target. All right, and but when you come into unsupervised learning, right, herein you don't have a target at all. And you're going to cluster it. Say I'm going to have an input data of apple, bananas, and mangoes. I don't have any output, but taking it to the shape and structure and the patterns of data, it is breaking into 3 clusters. An apple is one cluster, banana is one cluster, and mango is another cluster. Okay. So from the data patterns, as you all said, 3. Above average, maybe above 70%, below average, less than 40%, between 50 to 70, you say them to be average students. So this is one learning of the patterns, then it makes an unsupervised learning. Okay, and listen this very carefully. In machine learning, whenever I'm going to give a data, first here you go into the process of feature extraction. You will extract the features and then you move on to your classification. Like you develop your classification model. You remember it, right? You remember what is classification, right? Classification will have target or not. Whether classification will have a target or not. Whether classification will have a target or not. Yes, you will have a target, right? Here, same example I'm going to for in machine learning algorithm, you've got algorithms called feature selection and feature extraction, right? So it will first extract what are the necessary features. Say, for example, I'm giving my entire database of a student, their name, their address, their blood group, their Aadhaar number, their father's name, mother's name, every details I give it to it, right? I give all the details and also the marks. But if I want to only find out how does the student is a good student, learning student or not, I only need the roll number of the student and other marks. Other things I could leave it off. So for that, according going to your end results, I can go on for feature extraction or feature selection. Once the feature extraction is completed, then when it goes into the classification model, again we don't go into the feature extraction in machine learning. But in deep learning, the feature, I told, right, in every iteration it learns. You remember the example dark, and I can also see every interaction it learns and keeps building its network. So classification and feature extraction goes hand on hand in deep learning. Whereas in machine learning, once feature extraction is completed, when it goes to machine learning or the classification model, it will not go back to the feature extraction. Is the difference clear between machine learning and deep learning? Yes, no? Okay, I can give an unsupervised, I can give a new data. Here what it does the feature extraction grouping of object, goes into a deep learning algorithm and goes into the results. So what are the different Python applications that you can have, right? What are the different Python applications like instant visual translation? I told you, right? In natural language processing, it works really a lot. Predicting the future. Okay, maybe in astrology also it works. And also when you develop a model with the previous data, like we have 8 semesters, how the semester students, like 2 years before in 3rd semester, how many of them passed in 8th semester. So with the current data, you can also predict how many students will pass, how many students will be placed, something or the other. The chatbot, the medical care, the self-driving car is the best example of. Can any one of you give me an example of a self-driving car? Can any one of you give me an example of self-driving car? Yes. Tesla, rightly said, Tesla. All right, and coloring the images, therein we can use deep learning algorithms. All right, and then for reading the lips movement, you can use the deep learning algorithms, right, for deep photo description and for advertising. So now we are going to move into the, any doubts till now? Any doubts till now? We have started with what is ML, DL, AI, and predominantly the difference between ML and DL.
No, ma'am, no doubts.
Okay, thank you, ma'am. Only one response. Okay, others 2, 3. Now I'm going to ask you a question. How many of you are listening to this talk? If you're listening to this talk, type L on the chat. If you're not listening to this talk, type NL on the chat. Let me see how many responses I'm getting. If you're listening to this talk, type L on the chat. If you're not listening to this talk, type NL on the chat. Thank you. See, these are different methods for us to find out really how many of them are listening to the talk. Because if you ask any questions, you'll hesitate to listen, you answer. But this, it is just a reminder for us to know how can we answer if Balaji sir, you are answering all the questions. There are 100+ people here. Yeah, thank you. Some of them have not even given any responses, but this question they started giving responses. I'm happy about it. Okay, these are some simple reminders. Right now, let's move on to developing of your deep learning classification model. Ready? Okay, there are 8 steps to do it. So the first step is to create a deep learning model in Keras, right? I will tell you about what is Keras or TensorFlow. Anybody has worked in Keras and TensorFlow earlier? Keras, TensorFlow? No? Has it been taken up in the previous sessions? I don't know. No, thank you, Ajita ma'am. Okay, so here we are going to load in our data. First step, I told you, right, I'm going to take a diabetes data and I will show you the notebook also how it runs. And then we need to pre-process the loaded data. All right. Am I not audible? Oh my God.
Audible, ma'am. You're audible.
Okay. Like one ma'am has told I'm not audible. That's what. Yeah, thank you. Thank you so much. Right? Pre-processing, and you have to define the model. You remember how many layers generally, how many layers we have for deep learning? You have got an input layer, you have got your output layer, in the middle you have got set of hidden layers. So you have to define the model. And then the next step, after defining the model, you need to compile the model. After compiling the model, then the next step is to fit the model. And the following step, you have to evaluate it. And then you have to make what are the required predictions, how much is the accuracy of the model. And then we need to save the model. Once you save in the model, next for the next type of different inputs, when you give in the input, you'll be getting the output for it. All right. So these are the steps, right? These are the steps, 8 steps. First, you have to load the data, pre-process the data, defining the model, compiling the model, fitting the model, evaluating it, finding out the predictions, and then saving the model for the future uses. So these two words are very important. Listen very, very carefully. Listen very, very carefully about Keras and TensorFlow, right? As you remember, I told you for data science, 3 packages, NumPy, Pandas, and Matplotlib. These are very basic packages for your data science, right? So Keras and TensorFlow, when Keras is a Python library, okay, here you have a wide range of deep learning models already being done. Okay, Keras is the front end and TensorFlow is the back end. All right, Keras is the front end of your Python library. Here you have got lots and lots of deep learning model already being created, and it uses a back end, probably a TensorFlow or Piano. Right? So here, when you even Google it and if you find it out, you'll be able to find Keras. Right? You go just Google and find it out. Keras is a Python's deep learning API. Here you've got lots of from TensorFlow. What is TensorFlow? It is in a backend library. What is the front end library? It is your Keras, right? And so here. So this is what is the website of Keras, right? So here you've got lots and lots and lots of algorithms being deep learning models already being created, and in the backend they use TensorFlow. Now for this session, I'm going to use Keras and TensorFlow, right? It enables faster experimentation. Yes, using neural network only, these models, how students can take internship is we provide online and offline internships on all these tools, on anything the students they want, like machine learning, deep learning, and also we provide faculty internships too. Everything will be a live session and it will be a hands-on session, either physical session or an online session. Because why I think faculty internship, because some technology we should have not learned. Yes, I do provide it at the end of it, right? So sometimes we would have not learned what technology we have learned, but now we are teaching it for the students. Like I always think, when one student is one faculty is got trained, through them like thousands and thousands of students could be trained throughout your life. So that is what, and we have been successfully doing a set of faculty internships. When I initially people faculty internship is only for students, then I told, if it is for the faculty, the entire college and the entire set of students will also be trained, right? So this is the session that is going to come up. It's like 1 week session. Like we have 1 week, 1 month, 30 days, 40 days, and also even for research scholars we have like 1-to-1 session. Because why? For research scholars, basic training could be in a common platform, but when you get your ideas, that we train you in developing your some of them, they will have the problem, they will not know how to find solution. They will have solution, but they will not know what technology. We guide you through that. All right, and you will be developing it. We don't develop and give, you will be developing it, and we helping for error and debugging. Any mics on? All right, so this is for the 1 week internship for students between 1st August to 6th August. And also the next session, image processing, is coming for two months. That also will be useful for the students or faculties or anybody. No, it is not free. The training will have its own cost. Yes, fees details. You can message me for this one week internship. It is 3,000 rupees. It will be a hands-on session. Along with the students will be assigned. They can do a project, and also certificates will be given. All right, and it depends, like 1 month, and it goes on. So coming into this, right? It enables for faster. No prerequisites. We start everything from scratch, because all the students will not, they'll have different understanding. All right, so it enables faster experimentation, and it can work on CPU and GPUs too. So I told you, right, I'm going to take this data set called PIMA. PIMA is a benchmarked data set, right? So I'm going to use Keras model. I'm going to define a Keras model, compile it, fit it, evaluate it, tie it all together. All right, and I told you about NumPy, pandas, not the Kung Fu pandas, right? This is Python for data analysis. TensorFlow. TensorFlow is a front-end or back-end library? TensorFlow is a front-end or back-end library? Answers, please. Back and very well said. I'm happy most of you are listening, though it is post lunch. I don't always, most of the time I get post lunch sessions, right? And Keras is a front end tool, right? So it loads data, and for PIMA for diabetics data sets, right? So what happens here? You can run it on a CPU or GPU. CUDA, the lower level libraries, I told the backend will be TensorFlow, onto your front end, TensorFlow, Theana or CNTK, and onto the front end, it is Keras, wherein you have got lots and lots of deep learning models already being done. So I'm going to take this data set. So this is going to take about the diabetes data set, and my output is I told, right, whenever I have a target, what model it is. Whenever I have a target, what model it is. When I have a target variable, it comes under what?
Machine learning.
Classification. Rightly said. I don't know who's VPN son. Okay, he was the first to answer this question. It comes under classification model. When you don't have a target value, it comes under clustering, right? When you don't have an output variable or a target variable, then I'm going to find whether the particular patient is a diabetic patient or not. I'm taking the PIMA benchmarked diabetes data set. So what are the parameters on the column that I'm going to have? Number of times pregnant, right? I sometimes, maybe as women, I don't know, many professors would be there. Sometimes we have pregnancy only we have diabetes only during the pregnancy time. And post pregnancy it goes, right? Number of times pregnant, and the plasma glucose concentration, the GTT test. I don't know. I've got 2 kids, right? My first daughter is in class grade 10 and my son is in grade 5. When I was carrying my daughter, I had diabetes. When I had, after the post delivery, it disappeared. When I had my son, I didn't have diabetes, right? So that they used to give us GTT test. They used to give glucose so many times, and for 2 hours, and they find out your sugar level. So that's called glucose tolerance test, right? And diastolic. The systolic and diastolic, right? The diastolic blood pressure in the heart, you know, right? Systolic and diastolic, sometimes in your grade 8, 9, and 10, you should have learned, right? And triceps of skin folds, how much thickness is there, and 2-hour serum insulin, right? And the BMI, the body mass index, and then the diabetes pedigree function, and the age in years, right? And the age in years. So this will be the column headers, okay? And if it is 1, he is a diabetes patient. If it is 0, all right, if it is 0, it is a non-diabetic patient. So I told this is how your Keras model works. You have an input layer, you an output layer. It is not only 2 hidden layers. You can have n number of hidden layers. All right, there is no strong rule for it. There is no strong rule for it. All right. So I told you, right, Keras, it provides a complete framework to create any type of neural networks, right? And Keras is innovative and very, very easy to learn. Okay, it supports from today I'm going to show you an example of very simple neural network. And also in Keras you have a complex and larger neural network model. All right. So what in Keras you have got three categories. One is the model, the second is the layer, and third is the core modules, right? So listen carefully. At the end, we are going to have a live quiz. Like by 3:20, we'll have a live quiz, right? So this is Keras API, right? I have got three more categories. So here you have got what model you're going to use, what layer, and the modules. Like in Keras, every ANN, what is ANN? Artificial neural network is represented by Keras model. Okay, in every Keras model has got set of Keras layers, right? And Keras layers have got input layer, hidden layer, output layer, and also the other certain layers of convolution layer, pooling layer, and so much and so more. And every layer has got an activation function, right? And the loss function and regularization functions. The layers have got their own functions, right? So using Keras model, the Keras layer, and Keras modules, any ANN like CNN, RNN can be represented in an efficient manner. So when you take Keras, you've got three categories. What is your Keras modeling? That's the first one. The second one, what are the Keras layers? By default, you will have an input layer, you have an output layer, minimum 2 hidden layers and different layers. And in the hidden layers also, you can have convolution layer, pooling layer, and this and that, so much and so more. And you have your core modules. So how many layers are we going to do an activation function? You've got an optimizers also. I'll be explaining deep about it in each and everything, right? So the in the model, generally we go in for a sequential API or a functional API. So if we don't go in for functional, we go in for sequential. The models of API, you got a core layer, I told you, right? You will have a core layer, a convolution layer, pooling layer, recurrence layer, locally connected layers. So in core module API, how do you activate the layers, right? There are different functionalities for activations, right? There are different functionalities for optimizing, like ADAM optimizer, how it is the loss functions are being defined, the metrics. I'm going to show you the metrics is accuracy, and optimizer I'll show you. But ADAM, how do you initialize, how do you regularize it, what is the data set, callback, and visualization. So these are the three components of Keras. What are the three components? One is the model, the second is the layer, and the third is the core modules. Able to understand about Keras structure? It's a front end. Yes, no?
Yes, madam.
Thank you, sir. Thank you. All right. So I told you, right? Like you have a core layer, can have convolution layer, you can have a pooling layer, you can have recurrent layers too. So these layers are the building blocks of your neural networks, right? So a layer is have a tensor in and tensor out. The output of the previous layer will be the input of your next layer. All right. At the end, you have got one output layer. Okay. So this is about in your backend. This is about in your backend, right? So every layers are the building block of your thing. There are two things I told, right? The sequential and the functional. So sequential is very straightforward. It's limited to single input and single output. The hidden layers, you can have different things. But in functional API, right? This is what they use in the industry. Right? This is what it is for academic purpose to learn. We'll start with sequential model, and then we go on for model subclassing. When you are going to become an expert in deep learning, you can start developing a model right from scratch. Right? When you're developing a new algorithm for your research work, all right, then you can go on for model subclassing. But predominantly, when you want to learn about deep learning, you need to start it from your scratch, from the sequential model, then to your functional API, and then to this. And there are 4 things that I told you, right? Compilation, fitting the model, evaluating, and predicting. So training and prediction, training, evaluation, and prediction. So whenever I compile, there are 3 functions. One is a loss function, one is an optimizer function, and what is a metrics. So in this session, I'm going to take metrics as accuracy, optimizer as Adam's optimizer. Not only Adam, there are multiple optimizers available, right? There are multiple optimizers available. All right. And And here it finds the different weights and the learning rate and how to reduce the losses. Like it uses SGD, okay, SGD method for an estimation of first order and for second order moments, right? And the loss I'm going to use for this example today, there are different loss methodologies available. The thing that I'm going to use in today's session is binary cross entropy to determine how far the predicted value deviates from the actual value. All right. So using entropy, and I'm going to use a binary classification, whether the diabetes patient is or no, 0 or 1, right? For true tables and your predicted values. For your true tables and your predicted values. All right. And we need to train the model, number of approaches, how many times you're going to iterate it. Minimum you need to have 100 approaches. And then you will have like the batch size probably between 25. This is the general rule we follow. All right. And it generates an output for the input samples. And then we go on for your accuracy in your classification report. All right. Now I'll show you the example. Okay, you can see on my screen. So I'm using Keras.
Yes,
Yeah, Keras. Oh my God! Just give me a second. Okay, so you're able to hear me now? Yes.
yeah, ma'am, it is
Yeah,
audible.
yeah. So sorry, the charger was there. Okay. And then I'm importing pandas and numpy from Keras model. I told, right, two models are there: sequential model from model subclassing right from down, and functional API is that is used in the industry. For this session, I'm using sequential model. There are different layers. I'm going to use dense layer. Okay, so dense, it's just densely connected NN layers, right? What is NN? It stands for neural network. So I told you, right, what are the three components in Keras? You have a model, you have layers, and the next component, right? The models, the layers, and the modules, the core modules, the activation, the losses, what is the metrics to be used. That and all I will use it while I'm doing the process compilation. So these are things that I'm importing. So I have my data set on my Google Drive. So it is on diabetes. I told you that how many times pregnant, right? Glucose level. Oh my God, I don't know who's calling so many times. All right. And then the blood pressure, the skin thicknesses, insulin, the BMI, the diabetes pedigree function, the age and the outcome. What is 1 and 0 denotes? What is 1 and 0 denotes?
1 is diabetic, 0 is not diabetic.
diabetic. Thank you. And I'm going to find any missing values are there. No, I'm not having any missing values. I'm having 7 rows and 9 columns. All right. And then what is the type of data set? Though it is a CSV, when they load that data set into my pandas, it will be a data frame. All right. Okay. Wait for attendance and feedback link. It will be soon posted. Right? And I'm using a group by function. How many of them have got diabetes? Choose how many of them have not got diabetes. It is 500 in the entire data. And which I'm going to show you my histograms of the values of the data, right? Of all the columns. And then I'm to find the correlations. I'm using heat map. Right? It uses, there are three correlation. It uses Pearson's correlation, Kendall's correlation, and Spearman's correlation. By default, if I use dataset.corf, it uses Pearson's correlation. Okay. So it's a small and you need to visualize, a lot of visualizations. As I don't have much time, I'm not showing all visualization for the dataset. Only something like I'm using some. I told right, Seaborn is a higher level interface in comparison with Matplotlib. I'm using Seaborn and the data set outcome and how many of them. So in this data set, what could you infer? Who in the entire data set you have patients with diabetes more or without diabetes more?
Without diabetics more.
Thank you, Jemma. And then it's a heat map. So the correlation is more, the lighter the color, darker the color, there is no correlation. The correlation is less. Okay. And I'm splitting my data into data and my target. X is my fetus and Y is target. Y is zeros and 1 with diabetes, without diabetes. X contains all the other things, right? Other than the outcome, and Y will have. So now I'm defining my Keras model. Keras model sequential. I told you, right? Here you have got how many columns you got? 8 columns you've got, right? So you have 8 columns. So I put how many? Input dimension is 8. So I'm creating a dense layer. You remember I imported Keras. So dense 12 count, and then making it to be 8 and now you the layers. Remember I spoke about activation of it. I use more, and then for compiling, the next step when I compile it, I have 3 parameters. One is loss. I use binary cross entropy, optimize metrics accuracy, and after I compile, next step is fitting the model. Here I'm taking 150 approaches, 150 iterations. Each iteration it learns and finds I got a better accuracy in the batch size 10 of my feeds and my target. After and my target. Then I'm evaluating the accuracy of it. So I'm getting approximately 77% accuracy, and from which I'm moving on into the classification mode. Okay, the classification. Okay. So what's my predicted value? I already have my actual value. I'll compare both my predicted and my actual value. So I have my precision, recall, and waveform source. I don't have much time to explain about it. How much is the positive value? How much is the true positive, true negative, false positive, and false negative on the formulas that we use for precision, recall, and waveform score. All right. So remember the steps. Hello. So I hope you understand. First, we started with loading a data, that is diabetes data. Then we defined a Keras model in sequential. Then we compiled with 3 parameters, the losses, the metrics, and the optimizer. Then we fit it using our features and the target. And then we evaluated, found the accuracy, and we tied it all together. We found out the classification report and the making the predictions of it. All right. Now let's, I'll share a small link. You can just click on and then just click on and give your name, use device or your system is fine.
It says this is not open.
Yeah, just give me a second.
Yes.
1 seconds. We need to expect unexpected. Device, I'll try to share it. My next system. I hope you're all able to comment. There are 22 people comment. That's what I always have other system next to me. Not open now. Is it opening now? Just click the link. There is no code, nothing. Just click the link that I went onto the chat. I'll wait for just 1 minute until others are joining. It's the link. Just click the link, give your name and join. Yeah, it's activated. Thank you. 36 of you have joined. Forty-two have joined. Please don't leave. Be there. I have not started it. Okay, 45 come in. Okay. I don't know if you could make me to share my screen for the next name of Doreen Robin. It will be easy. The screen I'll start. Only those who are connected with the link will be able to see it. Ma'am, can make another Robin login as a co-host and share screen? Please.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
But I always have another system next to me ready. Yeah, less than 5 minutes we'll be completing it. Yeah. Thank you. Thank you. Hope my screen is shared. Yes. You're able to see my other screen?
Yes, ma'am.
Yeah.
Yes.
The first question: in which model does classification follows after feature extraction? First question. Yeah, 3, 2, 1, 31 of your answer. Does classification follows after? It's only in machine learning. In deep learning, it goes hand on hand. Let's see who's the winner. The first session, first round. Ma'am, come to the mentee and then give your answers. Shakti, so the professor is the first, the second is Jayanti ma'am, and third is Nilesh sir. We will quickly move on to the second question for the day. Which whether self-driving car is an application of deep learning model? Yes or no, or maybe? Jyotsna ma'am, kindly come using the mentee link, ma'am. That only it evaluates, it self-evaluates. Okay, yes, 31 of you have given the right answer. Let's see. Who's topping in the second round? Yeah, Shakti sir and Jayanti and Nilesh, and the fastest is Jaya ma'am. Third question for the day. Dash supports simple neural network model to very large complex neural network. Either it's Keras or TensorFlow or none of the above. Sabina ma'am, your answer here. Kindly the answer on Menti. All right, 27 of you have given because TensorFlow is a backend. Only Keras supports it, right? So let's see. Yeah, I again suppose Shakti sir keeps the first row. At the end of it, the topper needs to give a talk for just half a minute experience with ma'am and Jayanti ma'am. We go on to the fourth question of today's session. Sorry, of the quiz. Adam is A/N. During the session. It's a loss function or it's an optimizer or a matrix. During compiled session, compiling of Keras, I told. It's a loss function or an optimizer or a matrix. Let me see who answers it. Oh my God, 24 of you have given the right answer. Yes, Adam is an optimizer. Some of you are giving answers on the chat. Thank you for that. But evaluation will be taken only from the mentee. Yeah, Shakti sir is always on the first position. Jayanti ma'am, and I don't know who CT and SDK. I don't know. That's the fastest. The final question, which is going to define the winner of the day. Let's see to it. Metrics to compile Keras model. What are the metrics to compile Keras model? When I compile the Keras model, we give optimizer, loss, and metrics, all of the above, or only optimizer, or only loss, or only metrics during my compilation phase in my metrics model. All of the above, well said. That's the right answer. We have optimizer, loss, and metrics. Remember binary cross entropy, Adams optimizer, and accuracy. Let's see who's the winner. Okay, Jayanti ma'am is the winner of the day. Congratulations, congratulations, ma'am. Congratulations. So thank you so much. I hope the session would have been good unto you. And you have some feedbacks for the session for the next, you can give it out. And hopefully this session was your web session, and the session is also streamed on to my YouTube channel. I'll give the links to it. All right. Any doubts? You can share it to me, right? You can share it.
Any quiz from the participants, please?
Any queries? I'll just share my contact details or any internships or anything that you'd like to have. Wonderful, knowledgeable session. Thank you. Thank you, Jaya ma'am. I'll share you. Just give me 1 second. I'll share. Nice session. Thank you, Sudha ma'am. Any other queries? Thank you so much for kind listening and that to the post-lunch session. And really, you're wonderful. Thank you, Saranya ma'am. And the session video I will share with you. Yeah, ma'am has posted the feedback link. Thank you so much for the good responses. And the YouTube link. And whenever I come online, I'll always share it onto post events onto the YouTube so that it will be useful for the subscribers. Right? If you wish, you can subscribe to the channel and then listen to the future talks. Effective session. Thank you. Thank you, Shakti. It's a nice session. I really enjoyed. Thank you, Professor Chekan. Nothing much. Any queries? And this is our company's website, and we have interns. We also have full stack web developer intern, right? Any students who's strong in Django or Laravel, and I ask them to contact me. We have a simple interview process wherein the students will be asked to code in for with the front end and the back end, and we've got a couple of projects. After they complete the project, stipend will be given to them, right? A student in your student section who was good in Django and also with the SQL or MySQL or on it is in Laravel, right? Or any good content management system with the input and output, the front end and the back end. Please do share. You can contact me through WhatsApp or you can send a mail or to me. I've brought my contact details to you. Please do refer, and that will be a very, very good learning experience for the students, right? So when the students are thorough with the technology, they will be directly put into the live project after the process of interview, and they'll be paid after they complete their modules assigned to them. The reason behind, sometimes we pay them for monthly stipend, they don't complete the 6 months. It's a semester project, right? They don't complete it fully, and that's what after they complete their module assigned to them, payment will be the stipend will be given them. And also we have got training session that starts from August 1st on image processing, fully hands-on. That will be a 40-hour session. It will be very, very effective for students or staff or whosoever it is. If you're interested, please do join. And August 1 week, not 1 week internship. It will be between. It depends on the time, like morning or in the evening, or sometimes like it will be online session and also physical sessions. Anybody interested could join to it. All right, thank you all. Over to the organizers. Thank you, Anandi ma'am.
Thank you, ma'am. Thank you for your excellent input on AI, ML, and DL with a real-time example. It was so useful for all the communities. Thank you once again for your spending your valuable time with us, ma'am. Thank you, ma'am.
Welcome. Thank you so much.
Participants are requested to fill the feedback form that is posted in the chat box. And thank you for all your cooperations. Thank you all.
Okay. Thank you, ma'am. Kennedy?
Yes, ma'am. Thank you, ma'am.
Thank you so much. Thank you. Thank you all. Thank you, participants. Meet you all soon. Bye.